Now that we've discussed the beginning of the universe, let's actually look at the evidence in support of the Big Bang. One is actually the cosmic microwave background, which we talked about earlier. So in the 1960s, there were two engineers, Penzias and Wilson, working at Bell Laboratories. At the time, they were actually doing experiments trying to communicate with satellites in orbit around the Earth. Now, this is something that we take for granted today, but then it was cutting-edge technology. So they were figuring out exactly how to communicate, and they chose microwaves. Pictured here is their microwave observatory, referred to as the Horn. Well, as they were doing their experiments, they noticed that there was a weird microwave noise in their signals. Okay, so being good engineers, they went piece by piece through all of their equipment, making sure everything was connected and behaving as it should, and everything was good. Okay, so then they started wondering what else could be causing this. Well, they realized they were doing all of their experiments during the day, and we know that the sun emits radio and other electromagnetic radiation, so maybe it's also giving off the microwaves that they're detecting. So they did some experiments at night when the sun is not up, and they still noticed that it was there. Well, they're always pointing their instruments up because that's where the satellites are, so they pointed the horn down towards the ground because maybe it's the sky itself giving off these microwaves. Well, when they did that, it was still there. Okay, they noticed that a flock of pigeons had begun roosting within their equipment, and maybe pigeons give off microwaves. So they got rid of all of the pigeons and all the stuff that the pigeons leave behind, and it was still there. They did everything they could possibly think of to try and figure out the source of this weird microwave noise that they were detecting. Well, in the end, after taking care of everything they could possibly think of, they just had to accept that that there was this weird microwave background to everything. Well, at the same time that Penzias and Wilson were fighting with this microwave noise in their observations, there were groups of astronomers and physicists trying to figure out the conditions of the Big Bang. What was space like during this time? Well, one of them realized that early on everything had to be very, very hot. And if everything was very, very hot, then everything should also be glowing. So it's similar to the burner on an electric stove. When it's hot, it glows red. So, very early on, the entire universe was so hot, it was actually glowing. However, although the entire universe was glowing at that very early time, because of cosmological redshift, the expansion of space, that light that was originally given off as visible light should be stretched out and redshifted all the way to the microwave. And because the entire universe was hot and giving off this light, the entire universe should have this weird cosmic microwave background to it. Well, it didn't take very long for people to realize that what was being predicted by these physicists and astronomers about this microwave background coming from the very early stages of the universe is exactly what Penzias and Wilson had just discovered. They, without knowing it at the time, had actually discovered the cosmic microwave background. So this is the oldest light that it is possible for us to see. So this comes right after the period of nuclei in the period of recombination. Since that time, there have been several studies done to look at it. One of the first was the COBE mission. All this did was to show that the cosmic microwave background has a perfect blackbody spectrum. In other words, the shape of the spectrum of the cosmic microwave background is exactly what we expect it to be if it was produced by a very hot object, and then that light has been redshifted down into the microwaves. In the early 2000s, we had the WMAP mission, and then even more recently, we had the Planck mission. Okay, this ended in 2015. Both of these did all-sky surveys of the cosmic microwave background. That is what this image is. This is actually the full sky, and we see the hot spots and cool spots. Okay, so the red are relatively hot, and the cool are the cool colors, the blues, are relatively cool. Now, something I do want to point out real quick, the cosmic microwave background is actually very, very uniform. The temperature difference from the very, very hottest spot to the very, very coldest spot is about 10 to the -4 Kelvin. So they really, really had to tweak up the contrast to get this view of the cosmic microwave background. But we do see there are hotter and denser regions and cooler and less dense regions. The hotter, denser regions will collapse and form into galaxy clusters. The cool regions will have material swept out and will eventually form into voids. The cosmic microwave background actually shows the seeds for the eventual large-scale structure of where galaxies are going to form in the universe. Now, before we leave this, something that I want to point out. In my opinion, the cosmic microwave background is actually the strongest evidence for the Big Bang. Every so often, there are other ideas proposed about where the universe may have come from, how it could be here. My first question is always, explain the cosmic microwave background and why does it have a perfect black body spectrum? If you can't explain that to me, then I can't take your ideas seriously, because we know the cosmic microwave background exists, and we know that it has a perfect black body spectrum. So another evidence we have for the Big Bang is actually the chemical abundance. So if you remember, as we've talked about stars and galaxies and interstellar medium and all this stuff, we've talked about how it's mostly made of hydrogen and helium. This is evidence for the Big Bang. So during the era of nucleosynthesis, where the entire universe was hot enough and dense enough to begin nuclear fusion, we know what stuff went into that period, and we understand how fusion works, so we can predict what should come out from that period. Well, when we do, our models suggest that the universe should be made of 75% hydrogen and 25% helium with little bits of lithium and beryllium. And when we look at the primordial clouds, so these are regions of the interstellar medium that have had the very least influence of stars and star formation, this is what we find. Okay? And in everything we've talked about, we have mostly hydrogen and helium. Where everything else comes from is stars. So even the chemical abundance, how the chemistry of the universe is evidence in favor of the Big Bang.